Sarah, let me down. That hurts my feelings, Sarah.
Sorry.
That's bad. Math 35, last lecture day, day 27. We're gonna do 15.3 and 15.4. 15.3 is on geometric sequences and series. Sequences and series. And if you remember, we were doing this the other day. Each number is a multiple of the number before it. So for like example, 12, 24, 48, 90, 96. Oh shit, 192, I think is the next one. That's a geometric sequence. And here you can see we're multiplying by 2 each time. So the way they define the sequence as geometric, they say a sequence is geometric if the ratio of consecutive terms is constant. And they're going to give that constant the value R. And this stands for common ratio. What that kind of means is like if we take A2 and divide by A1, we get R. If we take A3 and divide by A2, we get R. If we take A sub n plus 1 and divide by A sub n, we get R. For any n. It'll be R every single time. You know what? I'm going to add a number in front of this one. I'm going to slap a 6 in front of it. And let's use this to figure out the formula. I showed you how to get the formula from for the arithmetic series on Tuesday. So if you don't remember the formula, but you remember how to get it, you can find it. We're going to do the same thing here. So I'm going to say A sub 1 equals 6. A sub 2 is 12. A sub 3 is 24. A sub 4 is 48. And if I need more to figure out the pattern, I'll keep going. But I think we can figure it out from here. So just like we did with the arithmetic, we tried to write it in terms of A sub 1. In the arithmetic one, the arithmetic one, it was like A sub 1 plus something. Here it's A sub 1 times something. Each time it's getting a multiplier of 2. So I could write this as 6 times 2 to the third. This is 6 times 2 to the second. This is 6 times 2 to the first power. Times 2 to the 0. So the next one would obviously be 2 to the fourth. But if we wanted to write this as a formula, we can see that this 2 is that R. So R equals 2. And it's gonna have an exponent on it, and it looks like the exponent is related to n. But it's not directly n. When n is 1, we've got 0. When n is 2, we've got 1. Just like it was with the arithmetic, it's 1 lower. And what's the 6? A sub 1. So a sub n equals a sub 1 times r to the n minus 1. This is the formula for a geometric sequence.
Can the net minus 1 change to another number and it still be that way?
No,
But this is the original.
right, like, because unless you don't start with n equals 1. Like if I had different numbering, that's the only reason this would change. Was based on how I numbered these, and I'm trying to make a relationship between these and these.
Well, so
So if I start with n equals 0, I would just say n.
so it could still, you could still have something called a geometric sequence, and it'd be like n minus 3 or just n or n minus 5 and plus 2 or something.
Geometric sequence is usually n minus 1. You write it in terms of that, and if you have to make modifications to other stuff, you do. Because it's related, like we want to say, I could use 0 here, but then like this is easy, I could say this is the first term. But saying it's the 0, then it lines up with n equals 1. First term, second term, n equals 2, the numbers match. If I say this is the 0 term to just make this n, the 0th term makes me sound like I don't know how to fucking count. Right? So we want to like stick with the counting system. So that's why we're sticking with n equals 1 to start with. And so we want it in relation to that. It's going to stay n minus 1. But it's not too bad. Why don't you guys find the nth term? If a sub 1 equals 3 and r equals 2. Write a formula for the nth term. See, that's when you know a student likes you. I can't change his grade. He knows his grade is locked. That's just some respect. Times. It don't happen that often. Hasn't happened to no one else has brought me, other than students in this class at midterm time. No one's brought me anything this semester. So it's not like it, or for any of my classes. It's not a common occurrence. So when it happens, it's like, that's nice. What'd you get?
Oh, good. I was just gonna say 3 times 2 to the n minus 1.
Yep. You might want to do it like that. But it's the same thing like this, just this way, the parentheses help avoid confusion on what the exponent's on. All right, that wasn't too bad. Page, pick up. You're like, why can't this be in the fucking test? These are pretty easy. Right, so the series shit, the sequence and series shit has been pretty easy so far, right? When it comes back, you're not gonna like it.
Yeah.
It's gonna come back with a fucking vengeance. So this one, I'm not gonna give you the R and the N. Or I'm gonna give you the sequence and you gotta figure out what's going on. So find a sub n here.
I feel like I have a question about rotation on this. How we're supposed to write. Whether it's like, or one overs.
Well, what do we need for this?
A1.
We need A1 and R. What is A1?
One.
1. What's R? How do we find it? You can either say what is multiplying by each, or you can take any two things and divide one number by the number before it. Here, I think doing like this one is actually pretty easy, 1/2 by 1. Doesn't matter which one we do, we're gonna get R equals 1/2. So a sub n equals 1 times 1/2 to the n minus 1. And I probably wouldn't bother writing the 1. I would just say 1/2 to the n minus 1. Because you don't talk about eating one apple, you just say I ate an apple.
So B1. Yeah, that's. This would be like if it was a really complex, like super complex pattern with like. 5,678, the next number is 9,000, so.
Right, where it's not something you eyeball.
Yeah, if it's not something you use the R. to Figure out R. But. If that's the pattern.
This is just for you, Davis. Compliments is an hour ago.
Yeah, I was gonna say, oh, like I recognize the 91.
So. Which is R. What's a sub 1?
Okay, so 1 would be 13.
So what's a sub n?
So then it's 13 times the parentheses 7 n minus 1 to the n minus 1.
So. What is a sub 7?
Oh, it would be the equation if n equals or equal to 7.
This one runs away from you pretty quick. The seventh term is in the millions. Yeah, there's that whole great problem. The fucking, it's a classic. You're given the option. I need to write this in my notes too. Given the option to have $1 million.
And I wish I was given the option to have $1 million.
Lump sum,
That's my own. I'm saying that's the real deal.
or for 30 days, no, starting at a penny.
Oh, penny.
And doubling each day. Which do you pick? Most people that have not studied or learned this math immediately say, no way that penny's getting that very high. But if we write this as, we look at this in terms of a sub n equals a sub 1 times r to the n minus 1. What is a sub 1? What is r? And what is n?
A sub 1 would be 0.01.
0.01, it's the penny. What's r?
R would be 2.
R is 2, it's doubling. What's n? 30. So this a sub 30 would be the 30th day, just the 30th day by itself. 0.01 times 2 to the 30 minus 1 is 29. I hope my calculator will give me an answer. A sub 30 is $5,368,709.12. A sub 29 is half that. You're looking at 2.68 million. A sub 28 greater than $1 million. So like you're looking at probably a good 10 to 11 million net if you add it all up. But it doesn't seem like that. You're like 1 penny, 2 pennies, 4 pennies, 8 pennies, 16 pennies. On day 7, it's a week, and you gave me 64 motherfucking cents. But it starts going up pretty quick. Day 8's $1.28. Now you're up to $2.56. Then $5, then $10, $20. Now I'm rounding the whole numbers. Then $40, then $80, then 160, 320, 640. 640 in a day is pretty good for a lot of things. 1,280 is really good for a day. 5 million, phenomenal. All right, another question in this lineup. Was that not fun?
Yes.
What about if we have a sub 4 equals 125 and a sub 10 equals 125 over 64? We did something like this as the very last problem with the arithmetic, saying like we're not given a sub 1 or the thing. We still need to find both, don't we? We still need a sub, we need a sub 1 and we need r. I can write a sub 10 though as a sub 4 times r to what power?
R to the N minus 4.
Yeah. It's 10 minus 4, so 6th power. So I can do that. 125 over 64 equals 125 times r to the 6th power. I can plug in what I know. So 1 over 64 equals r to the 6th power.
Just take the 6th.
This is 1 over 2, 1/2 to the 6th power. So r equals 1/2. Or you could take the 6th root. Wherever you want to do it. I've got r equals 1/2. Now, how can I find a sub 1? We're gonna do something similar, but we're gonna have a sub 1 right here. So like, let's do a sub 4 equals a sub 1 times r to what power here? 4 minus 1 is 3. So we've got a sub 4 is 125 equals a sub 1 times 1/2 to the 3rd power. Which is 1/8. So multiply both sides by 8. And that's 1,000. So the a sub n formula is 1,000 times 1/2 to the n minus 1. Did I do something wrong? Absorbing, processing. Okay. That was sequences. Let's talk about series. There are 2 different formulas. So the sum of a finite geometric series. I equals 1 to n of a sub I, or not, sorry, a sub 1 r to the I minus 1 is, we say s sub n for it. And it's a sub 1 times 1 minus r to the n over 1 minus r. Now, if you were here over the last hour, we did a lot of like 3 or 4 of these, 1 minus r to the n over 1 minus r for practice. If you want to see some more practice and you weren't here, watch the video later on after it's uploaded. But we will have some problems in here today with it. There's no walkthrough for it. You'll eventually, there's a walkthrough for it when you're taking like calculus. You might, depending on, it might be calculus 2. When you start doing series. Chapter 9 in the book that we're using right now is sequences and series. For calculus, and that's calc 2. But it's important, note. This is related to something Davis asked the other day. I starts at 1. And exponent of I minus 1 are a must. They have to be this way. You asked the other day if we could start with like I equals 0 or I equals 3, and we showed that it changed if you did. We did an example and got different answers. So rather than doing that here, I'm just gonna tell you. This is a requirement. So if it's not in this form. Manipulate it so that it is. And we'll have some practice today. I'll walk you through doing this. Let's start off with a simple example. Let me give you a second to write all this shit down though. All right, first example. N equals 1 to 5. 81. Negative 2 times negative 1/3 to the n minus 1. So that's my 80 sub 1. That's my R. Index starts at 1, check. And exponent is n minus 1, check. So S sub n equals a sub 1 times 1 minus negative 1/3 to the 5th power over 1 minus negative 1/3. Be careful with the negative signs. This is 1 minus negative 1 over, let's see, 3, 9, 27, 81, 243. This is 1, I can, 2 minuses make a plus. So that's 1/3. So there's a lot of fractions and fractions here, right? And everybody loves fractions, love on fractions and fractions. So we'll have some of these today, but like, if you want more of them, watch the video, get some practice in. So this ends up being, I got 81, the top is, that turns into a plus. So I've got 1 plus 1 over 243. I can write the 1 as 243 over 243. So this will be 243 over 243 plus 1 over 243 all over I can write this as 3/3. And I'm deliberately going a little bit slower to make sure everybody sees what he's going along each step. Cause let's face it, fractions suck. Fuck fractions, I vow, I testify that that is the best policy. For things with a common denominator, we can add them. So I'm deliberately showing this slower than I would normally do this. Just show each step clearly. You should eventually get to this spot right here. And this is where, like, what do we do? So still, fuck fractions. It's a valid policy. If I don't want a fraction on the bottom, I can make this equal a 1 on bottom if I multiply by the reciprocal. So flip that motherfucker over. But if I multiply the bottom by 3/4, I'm changing the value unless I multiply the top by 3/4 as well. So this ends up being 81 times 244 over 243 times 3/4. Now, I don't know if this helps any, but I know this was 3 to the 5th power. And that's 3 to the 1st power. And 244 looks like, does 4 go into 244? 61. So 244 is 61 times 4. So I could write this as 4 times 3 all over. I'm going to write 3 to the 5th power is 3 to the 4th times 3. And then times 4. I'm going a little bit slower on canceling stuff out to show everybody where everything's coming from. And let's see, we got a 3 that cancels. We got a 4 that cancels. 6 is 2 times 3, isn't it? Oh, wait. What is 81?
Oh, 60.
81.
So 2, you know.
81 is 3 to the 4th power. 81 is 9 times 9 squared times 3 squared. So 81 is 3 to the 4th power. So the 81s go away, leaving, and when we cancel, we leave behind 1s. All I've got left is 6. What? How do we have this? And it ends up as 6. This is called a problem that's tailored to have a nice answer. Reality doesn't come that way. Reality comes with shitty answers. Nothing is nice, round, even integers. This is an entirely different story. That's an 80 in front. You know what I mean? That's an 80 and not 81. This is a fucking lot uglier. Because then there's no 3 going into 80. That's what I mean by tailored. Don't believe me? Plug in 81 times 244 divided by 243 times 3 divided by 4, and you will get 6. Or I fucked up somewhere in my math. Davis doesn't believe me. He went for his fucking calculator. That hurts, Davis. That hurts. That's just insulting. Wait.
Yeah. Oh,
That's not a 6, that's a 61.
yeah, 61, yeah. Yeah,
Still, nice whole number.
yeah, nice.
I'm like, don't believe me, check it. And he's like, I will. All right, next problem. Bum, bum, bum. What's A sub one here? What's A sub R, or what's R? I point to it. Are my criteria met?
Two, yes.
No. This one is met, but this one is not met. I need the exponent to be n minus one. So how do we make it n minus one? Well. What do I gotta multiply two to the n minus one by so that I end up with two to the n?
8.
What?
So you multiply it by 8.
No. Like if I have n minus one here, but I started with n. I mean, I wanna end up, I wanna have two to the n minus one, so I gotta peel something off. We're gonna use the 8 later. I gotta peel off a 1. I can write this as n equals 1 to 8. Of 5 times 2. Times 2 to the n minus 1. You see that? These two piece back together make 2 to the n. So apparently my a sub 1 has changed. That's a sub 1 now, which is 10. R is 2. So now we can do it. S of n equals a sub 1, which is 10. And then we had, let me write the formula again because it's on another page. One minus 2 to the 8th power over 1 minus 2. Bottom is -1, that's pretty nice. Let's see, 2 to the 8th is 2, 4, 8, 16, 32, 64, 128, 256. Is that 1 minus 256 right there? And then a 10. I think. Got my calculator up. Yeah, 1 minus 256. So I got S of n equals 10 times negative 255 over -1. The negatives cancel out. I get 2,550. If I write out 8 terms, that's apparently like 5, 2 to the n. 10 plus 20 plus 40 plus 80 plus 160 plus 320 plus 640 plus 1280. That's 8 terms. Your practice midterm, I'm either making it tonight or tomorrow morning, depending on how energetic I feel like, or how much I want to actually work when I get home. But it should be up by noon tomorrow. I may or may not make a video for the solution. I thought I'd poll you guys to see what you wanted to do for Tuesday. I can either walk through it live. The full, like I said midterm, I mean practice final. I can walk through the practice final live on Tuesday. Or I can make a video for it over the weekend and we can talk about other shit. Like any questions, like any like, how do I do this or how do I do that?
Yeah.
You guys like that?
Yeah, what do the people online say?
What do you guys think online?
I would prefer if you do like the online video and we come in with the questions that we have.
Okay. Now, I'm sure I'll be doing questions related to the fucking practice anyways. But ideally. You'll have tried it. Try all the problems. Check the answers. I'll have the like steps worked out. And like if you don't understand one of the steps. Or something like that, or like you got something different and you like can't follow what I did. Then we can talk about it then, but hopefully that way we don't have to go through the whole practice fine. It will be cumulative, simply because if I focus on the last half. I will eviscerate this class. The last half of this, everything since the midterm has been logarithm, exponents, conics.
Oh, wow.
And the polynomial fucking graphing and shit. So like if I make a fucking whole test based on the hardest shit in this class. So there will be other problems in it from the first half. It'll probably be about 20 problems. An assortment from this selection.
What's the total length? What's how many questions are there in total?
20,
Oh, 20 in total.
that's what I said. Pay attention, Davis, it was a test. Alright,
We'll all do amazing here.
We'll all do amazing.
I'm probably playing the video game when you guys take the test. Now I'm torn between Jedi Survivor, which I downloaded on my laptop. I'm also playing this game on Steam. It's actually still on sale tomorrow. It's called Tower of Time. It's actually pretty fucking fun. It's like $7 on Steam. And I've been playing that. That's like low pressure. I can fucking hit pause. And look around and check to see if he's over here fucking cheating.
The Tower of Time.
But Jedi Survivor, I don't think, there's no pause.
I need time.
I just gotta find a spot. Yeah, I gotta find a spot where there's nobody coming at me. Which is doable, but I can always pause the other one.
Yeah.
And if I'm playing Survivor. If you hear the fucking buttons clicking on the remote a lot, I'm clearly in combat, that's the safest time to try to cheat. Cause you know I'm busy, but the fucking other one is just mouse and fucking. It's real slow, I can just pause it anytime I hit the space bar. We don't want cheaters. Cheating's bad. Alright, that was fun. Let's fuck it up even more.
This class was too fun to be in. Why would I be cheating?
Yeah, I know.
That's an excellent question. A better question is whether or not it's fun is, should I know how to do this shit for my major?
Yeah.
And if you're in this classroom, the answer is yes, because otherwise you wouldn't come down this class. You would take stats or 44 or 5 or 10 for general ed.
I feel like taking this class, at least in this last topic, how it actually covers a little bit of stats. I feel like it might be a good prerequisite before stats, but I don't know.
Guess what? It used to be.
Oh, really?
You know how I told you
Yeah.
that they're doing the whole 1705 and pretty soon you can't have even this class or trigonometry, which is pre-calc B for calculus? Well, that was AB 1705. AB 705, the one that was 5 years ago, said stats can't have any fucking prerequisites. We had algebra, like 2 like easy algebra courses. You could easily start in the second algebra one. Cause this is like algebra 1 and algebra 2 put together. Algebra 1 was like all the review shit that we, you know. So like if a lot of people coming in, if you did algebra in high school, you could start in algebra 2, have one class. And they're like, nope, you shouldn't have to have any fucking prerequisites. Everybody should be able to do just math instantaneously because everybody's good at math. That's the assumption. It drives me nuts. Because the assumption behind those laws is like everybody is good at math. And that's not true. Everybody can do math, yes. Everybody can do math. But everybody doesn't start, doesn't come quickly to everybody. Some people need more time, and if I can let them have fucking time. All right, we got two problems here. What are the problems?
It's not the right format.
What's wrong with format?
It's not, it's not n minus one, so it's not I minus
So we need I minus one here. Anything else?
one. I is equal to 0 below the signal.
Yeah, we need this to be one. All right, so if I were to write this, just freehanding it, I could do I0 plus I1 plus I2 plus I3 plus up to I6. This is the I equals 1 to 6 part. Which means we need to peel off I sub 0. Or I equals 0. So we'll do that first. I equals 0 is 5 times 1.08 to the 0 power. Plus I equals 1 to the 6th power. 5 times 1.08 to the I. What does this equal? What?
Oh, no, 5.
It's just 5. Anything to the 0 power is 1. So that one, that's not too bad. So now we're here. And we're gonna do what we did up here. When it was off by 1, we peeled 1 off. So I'm gonna write that as 5 times 1.08 times 1.08 to the I minus 1. And I think that 5 times 1.08 is 5.4. And now we're in the right form. So. What we got? We've got 5, oops, that's not 5. 5 plus A sub 1 is 5.4 times 1 minus 1.08 to the 6th power over 1 minus 1.08. Well, now we're in decimals, and rather than switching to fractions and trying to do it that way, I'm just going to do this part in my calculator. 1.08 to the 6th power is important that I type in 6, not 8. If I do this, I have 5 plus 5.4. The top is 1.586874323. And it's got more decimals. So this has got some more decimals, so this is rounded and I don't like it rounded, so I'm not gonna do that. The bottom part I can get pretty easy without rounding. Negative 0.08. So for the calculator portion, I am gonna do 1 minus 1.08 to the 6th power. I'll hit the equal sign. And then I'm gonna do answer divided by 0.08, and then I'll switch the signs to deal with the negative.
Well, we could turn the 1.08 into a fraction.
We could.
Because it would be 1 and 2/25.
All right, Davis. Davis asked for fractions. I just want you all to know that. He said, let's do fractions. 1.08 as a fraction is 108 over 100. So this is gonna be 0, 0, 6 zeros. We'll have a 1,000,000. So my top part is gonna be 1,000,000 minus something. Minus 108 to the 6th power.
100 to the 6th power, 3 over zeros.
You're right, that is a lot more zeros, that's off. That's 12 zeros.
Yeah.
Holy shit. So this is, are you sure you wanna go down this road?
Yeah, that's not.
Let's not go down this road.
I'm saying.
Like, I don't even wanna write the fucking fraction. So what I'm gonna do is that shit I said before. 1 minus 1.08 raised to the 6th power. What's 6th power, right? Yeah. And then I'm gonna divide it by 0.08 and I can make it negative. Multiply that by 5.4. And I would probably go to 2 decimal places because that's what we started with. So. Fuck fractions so much that I'm gonna undo fucking Davis's request. I'm gonna supersede him and say no. Because writing 10 to the 12th power is a lot of fucking zeros.
Well, can you write it in the scientific notation and just kind of?
Really? Then I gotta go over scientific notation?
That's the problem. That's the problem.
You do that in your fucking chemistry class. Alright. That is finite sequences. Thankfully. The sum of an infinite. Geometric sequence is easier. Similar format, I equals 1, a sub 1, r to the I minus 1, but we're going to infinity now. Now we don't say s of n, we just say s, which is for sum. Is a over 1 minus r, a sub 1 over 1 minus r.
Well, how could that be the sum if it's in?
You dare question the great and powerful laws? It's geometric, so it's multiplying. And so like if r is less than 1, this actually goes down and ends up being small. It may not be small, it may blow up to really big. It may be infinite. But no, it's not. I feel like I'm missing something here. Fucking Davis has got me second guessing myself. God damn it. You see what you do? I want to say R has to be less than 1 here, but like now I'm not sure.
Well, it's R is below the A1, so it's by nature kind of fraction.
following.
Oh, yeah, it very much is a requirement, if absolute value of R is less than 1. If R is bigger than 1, you are keep adding something bigger. And like, it's gotta keep getting smaller, and like, it only gets smaller if R is less than 1. I'm missing the constraint. This is called the constraint. So -1 is less than R, which is less than 1. It can't even equal 1.
Jeez.
Because otherwise you're adding a sub 1 plus a sub 1 plus a sub 1 plus a sub 1 an infinite number of times. It doesn't matter what it is, it's gonna add up to infinite. Alright. It's a good thing Davis is here to call bullshit. Let's look at some examples. Then we'll take a break and we'll do 15.4. What's a sub 1?
Well, you know, let me guess. An educated guess.
There should be no there should be no guessing. Should be able to flat out tell me what the value is. But let's hear your guess. Let's see if you know what it is and you're just like not confident and that's why you're saying guess.
I'll follow me. Base of 1 is 2/3.
No. What is 2/3?
That's R.
That's R. Match these up.
Yeah, it's up there.
Match these up. That's R. What's a sub 1?
A 1.
1. There we go. I knew if you started matching shit up, you wouldn't guess. You said it confidently. I know what that is. It's 1. You gotta stop and think all the time. Don't just like throw shit out. That's how you get made fun of. Not by me. I wouldn't make fun of you for doing that, but your peers will. Especially when you get into the higher mathematics, they'll make fun of you. So just like. If you start saying like 4 divided by 2 and you leave it like that. If I see 4/2 left in your fucking problem, I'm gonna make fun of you because fucking a 3rd grader knows that 4 divided by 2 is 2. Right? You don't leave shit you know. Alright, so. S equals a sub 1, which is 1 over 1 minus 2/3. 1 over 3/3 minus 2/3. So 1 over 1/3. What?
Yeah. That's the sum of the entire series.
That's deep.
That's weird that you could take 1/3 out to infinity and somehow you.
This is 2/3 plus 4/9 plus 8/27 plus, and somehow that gets to 3. Right? Is that not a WTF?
That's true. I think it's that. Would that make it kind of like an asymptote of 3? That somehow like graphical as an asymptote of 3?
I would think so. I think it's approaching 3, but never actually. Since it's going,
Yeah, that's.
but it's probably 2.9, and then I just keep going. In fact, I'm confident that's what it is.
Just those first 3 terms were a good way there, the 3. Yeah.
Oh, I'm missing one. I'm missing a sub 1.
Ah, that's what it is, yeah, that's what it is.
All right, how's that? Let's take a 5-minute break. Then we will do 15.4. The glory, oh, do not come up here. I too